The multiverse, often described as the theory of parallel universes, has extremely far-reaching implications. It's an idea that has taken over Hollywood and the science fiction genre as one of the premier plot points or narrative twists. But broadly, and in the real world, the theory argues that there could be countless other universes existing alongside our own, without us ever even realizing it. These universes could be completely different from everything we know, or extremely similar to our own. There might be a universe where the only difference is that you own a cat instead of a dog, but there could also be one where humans never evolved and completely different life forms crowd this planet. From the sublime to the absurd, there's an unlimited variety in the realities that could be possible if the theory is correct. And ultimately, everything will eventually be real. Perhaps one of the most bizarre suggestions spiraling off of the multiverse trail is that with enough parallel universes, it should mean that even everything that's ever happened in every fictional world here in our reality should have also happened in actual reality too, from the Seven Kingdoms to Middle-earth. But that's for another video. With the wider multiverse, proving such a theory is naturally much harder than simply imagining it. And from the beginning, some scientists would argue that the idea shouldn't even be considered real science at all, since the multiverse theory isn't falsifiable. That is, it isn't able to be disproven. At the same time, many others accept the theory and argue in its favor. Not all believe that falsifiableness is a necessary condition. The physicist Sean Carroll, for instance, argues that falsifiability in science should be removed altogether, because the inability to prove a theory false doesn't mean it isn't real. Beyond that, though, the idea of the multiverse is at least rooted in hard and accepted scientific thought. Cosmic inflation, quantum mechanics, and the Big Bang can all be tied to the concept. Within quantum mechanics, for example, we can flesh out the many worlds theory, which holds that subatomic wave functions form an endless stream of universes, one we observe and countless others we don't. But still, what about physical evidence? It could actually be more within reach than ever before, because scientists have found a number of problems in our reality, problems that seem to suggest that an alternate universe is out there. Some potential evidence for parallel universes comes from the mysterious cold spot in the cosmic microwave background radiation, or CMB. The CMB is the earliest light that we have in the universe, and is actually leftover radiation from the Big Bang itself. It therefore provides us with a map of sorts of the universe at the very beginning of time. Studying it has raised a major issue, however. While for decades, researchers had assumed that the universe is homogeneous, meaning that it's structurally similar throughout, a detected cold spot threw that assumption out of the window. This CMB cold spot has a significantly lower temperature than the space that's all around it, and is also surrounded by a strangely hot outer ring. Arguably, one way of viewing it is as a glitch in the universe. Some scientists prefer, though, to describe it as a potential scar. If we view a universe as an individual bubble in a bathtub, the scar theory begins to make sense. It's easy to see how that bubble could then push up against another, i.e., another universe. Were that to happen, though, you'd expect there to be some kind of sign of impact. It's an event, a truly colossal event, that might very well leave a scar of sorts on space. The wider implication being that anything that can dent or imprint our universe would have to, potentially, be massive on the scale of another universe? At this point, it's important to note that there are other suggested explanations as well, however, such as that the cold spot could be due to the Eridanus supervoid, a vast billion light-year plane of low mass and activity in the universe between us and the CMB cold spot. The supervoid theory isn't yet confirmed either, though, so the debate rolls on. Elsewhere, and one of the more commonly argued points in favor of the multiverse actually refers to the overall composition of our universe. It starts with a seemingly simple question: is the universe flat or curved, and does it have an end? But for the most part, there's no solid answer here. Scientists can't say definitively that it's one way or another, although the argument for flatness, or close to flatness, perhaps just shades it in terms of popularity, particularly as most studies of the CMB have yet to find solid evidence of a true curvature. Meanwhile, we've also never seen an edge to the universe, and don't have much reason to assume that there is one. So according to some models, these very conditions lend themselves perfectly to the multiverse theory. Here we enter into the Tegmark model. Set out by the renowned physicist Max Tegmark, it proposes that there could be as many as 4 levels of multiverse, waiting for us to discover them. But if the universe is flat and infinite, then really we need only look at the first and lowest incarnation, because across a flat and endless realm, a multiverse is seemingly unavoidable, so the theory goes. In truly endless space, there's the possibility for every single variation in particle placement possible, repeated over and over and over again. This means that far enough away in space, for example, there's a complete recreation of our own solar system down to the exact number of people alive on Earth at this very moment. In true infinity, it's not just likely, it's a certainty. Of course, there is some challenge as to whether this could ever constitute a genuine multiverse, rather than simply being a far bigger than we tend to imagine universe. But in terms of parallel worlds, Tegmark's Level 1 could provide them. Tegmark himself has before described this version of the multiverse as trivially obvious, because how could space not be infinite? But finally, we head south for a study that further provides some potential evidence for the multiverse as well, although it's not what those behind it were actually looking for. In 2006 and in 2014, an instrument in Antarctica known as the Antarctic Impulsive Transient Antenna, or ANITA, picked up a few strange readings that it was unable to explain. And after years of analysis, a paper in 2020 continued the mystery on. ANITA is a giant balloon stationed on the freezing continent. It's designed to pick up radio signals from high-energy particles that crash into our atmosphere. But in 2006 and 2014, it recorded multiple readings of errant neutrinos, which are ghost-like particles that move through matter. These neutrinos were seemingly traveling through the Earth, or at least from the ground up, and behaving in unexpected ways. While neutrinos in themselves aren't wholly unusual, they're generally produced in the atmosphere, and their path is easy to track towards Earth. But not this time. Based on their energy and direction, these neutrinos had some other origin story, but we're still not sure what that story is. It could be that on the 2 occasions that it was clocked, ANITA had simply malfunctioned. But the other possibility is that there's something going on beyond what we understand. One of the subsequent theories, then, is that what actually happened here was that the neutrinos seeped through to our reality from another universe, and even, perhaps, that they behaved in essentially the opposite way to what we'd usually predict because, in their universe, time flows backwards. What's your verdict? While none of these theories and studies show the multiverse with absolute certainty just yet, might science have already cottoned on to the true nature of what's really around us? As Carl Sagan famously said, extraordinary claims require extraordinary evidence. So is the evidence already extraordinary enough? For now, some scientists are convinced that what we know about the universe so far is enough to assume a multiverse, although some others continue to refuse it until we get hard and undeniable proof, such as actually visiting a parallel world. The quest for knowledge continues, but if the multiverse were true, would you want to meet another version of yourself in at least one of your realities? It's answers in the comments.